On problem number 10, we have a section of a wall. This side of the wall is hot, temperature T1. This side is cold, temperature T2. Hot and cold, of course, are relative terms. Now this is just warmer than this one. And we use red for hot and blue for cold. Okay, and the wall has some thickness L. Now, if this side of the wall, and if this is just a section of a much larger wall of uniform thickness L, and we're assuming also implicitly that the wall material is all the same, then if this side is held at temperature T1 for a long time, this one at temperature T2 for a long time, then what will happen is the temperature versus position in the wall curve will go linearly from T1 down to T2. Temperature's T1 over here at this side, where we say, let's let this be the x equals 0 point over on this side, and then x equals L on this side. So that we have temperature changing from T1 to T2 over distance L. And that change will be linear. Okay? We won't go into the reasons why that's true. There's symmetry arguments, there's experiment, etc. There are a lot of ways that we see that that's the case. In any case, just accept that this will be linear under those conditions. Again, where this has been at T1 for a long time and this one's been at T2 for a long time, we approach this steady state constant slope temperature versus position graph. Now, the slope of this graph is the rate at which temperature changes with respect to position. The slope is the rise over the run. The rise is your change in temperature. The run is the change in position, the distance you move through the container, the wall. And the delta T then is just T2 minus T1, and the delta X is L. So this is the slope. This also has the name temperature gradient. Okay? So the temperature gradient is delta T over delta L, which is T2 minus T1 over L, which is less than 0. Because, by our assumption here, T2 was less than T1. So as we go to the right, temperature gradient's negative, which means the temperature gradient is pointed to the left. Now we can depict that. I hope you can distinguish the colors. The temperature gradient vectors are these little green vectors that point to the left. Again, x goes to the right, the temperature gradient is negative, so the temperature gradient goes to the left. The energy flow goes opposite to the temperature gradient. It goes in the direction of decreasing temperature. The temperature gradient points in the direction of increasing temperature. Okay, so we have an energy flow opposite to the temperature gradient, and that's a concept of a temperature gradient. And again, the temperature gradient is the change in temperature divided by the distance over which the temperature changes.